Okay, so 2.4b, more chain rule. 17, 19, and 21 are pretty straightforward. They are chain rule. It has an outside function, but the derivative on the inside is pretty simple. For the first two, it's just 1. For this one, the derivative on the inside is going to be 3, which changes our problem a little bit. Then 23 is actually where it gets interesting. 23 is a function x squared times another function. So this is product rule, but when we go to do this rule, we're going to have chain rule as part of its derivative. So I've got them in different colors. I don't know if you can tell very well, but x squared is the first, and then x minus 2 to the fourth is the second. So I'm going to do product rule. X squared times the derivative of x minus 2 to the fourth. That's going to be 4 x minus 2 to the third times the derivative of the baby, which is 1, plus the second, x minus 2 to the fourth, times the derivative of the first, which is 2x. And then this I can simplify. I'm going to rewrite it a little bit simpler. I've got 4x squared, x minus 2 cubed, plus 2x, x minus 2 to the fourth. And from that, I've written my problem down wrong the first time, sorry. From that, I can see I've got common factors. So the way they wrote it in the book is eventually we're going to take a derivative and set it equal to 0. So I'm going to have to factor it to be able to solve it. So these answers are all given in factored form. This has a common factor of 2, and I can take out an x. I can take out an x minus 2 cubed. That leaves me with 2 times 2 is 4. X times x is x squared, and I took this out entirely, plus 2x, we took that out, and we took out x minus 2, we took out 3 of them, so we have 1 left. That gives us 2x, x minus 2 cubed times 3x minus 2. And then if we were to actually solve this, we could set this equal to 0, this equal to 0, and this equal to 0, and find out where the derivative equals 0. So there's 23. Also, while I'm here, also note that you can go to CalcChat, which is on the front of your book, and you can look for our book, which is this one. We can view it, and it will give us some answers. We're in Chapter 2, Section 4, exercise. The one we just did was 23. Go. And it will give us all the steps for that. Sometimes we'll have a video, sometimes we'll have steps. So you can use this website to help you with the problems and see where it is you get stuck. When you see the plus sign, you notice it was product rule, things like that. Okay? All right, so working 25, it is also product rule. I'm going to rewrite it. I prefer to have the right problem down, but I also prefer to have 1/2 as a power. So y prime is going to be first. Derivative of the second is this whole second right here. Is going to be 1/2, 1 minus x squared to the negative 1/2 times derivative of the baby, which is negative 2x. So this is the u prime here. Plus 1 minus x squared to the 1/2 times derivative of x is 1. This is hard to follow, so I'm going to multiply out things and simplify. I've got x times x. I've got y prime equals x squared. X. Got a negative x squared. I have 1 minus x squared to the negative 1/2 plus 1 minus x squared to the 1/2. Again, I need to factor it. So we're going back to chapter 1 in precalculus, which is we have the common base, and we're going to take out the smallest exponent. So we're going to take out 1 minus x squared to the negative 1/2. We're going to put the leftovers in a bracket. We took this out, so we have negative x squared plus 1 minus x squared. We took out, we subtracted negative 1/2. That makes 1 got 1 minus x squared to the 1 power. It's a 1, not a prime. So that gives me, I'm going to simplify on top, negative x squared minus x squared, negative 2x squared plus 1 over 1 minus x squared to the 1/2, or negative 2x squared plus 1 over the square root of 1 minus x squared, if that's all in there. So check that one, CF. And the book switched the order in the top, but that's fine. So 25. This is going to be much easier to solve if we say this is f prime of x or y prime or however you want to write it, if we were to say it's equal to 0, because we would just set the top equal to 0 and be able to solve for it. Okay, so 27 is similar to the last problem, except when I rewrite it, I'm going to have x squared plus 1 to the negative 1/2 here. It's still product rule. It's going to be first derivative of the second, which is chain rule, plus second derivative of the first, which will be 1. So I'm going to use dy dx here just to change up my notation. It doesn't matter. You can write y prime or f prime of x. I'm going to do first derivative of the second is chain rule. So I've done this. It's here. Now I'm going to say negative 1/2 times, keep the baby, new exponent, negative 3/2 times derivative of the baby. So this is u prime right here, the derivative of the baby. This is first, and this whole thing is derivative of the second. Product rule says plus. The second, x squared plus 1 to the negative 1/2 times derivative of the first. So this is second derivative of the first. Okay, so we've done all the work. Let's simplify it and see if we can tell what's going on, because our goal eventually is to set this equal to 0. So now dy dx, the derivative of y with respect to all these x's is 2 and 2 cancel. I've got negative x times x, so negative x squared times, so I did this and that and that, x squared plus 1 to the negative 3/2 power plus x squared plus 1 to the negative 1/2 power. We're going to factor out this common factor. I can't solve it like this. We have to factor it so we can set it equal to 0 and get our tiny equations to solve. So I need to go ahead and factor this. It's the best way to see the derivative. I'm going to have x squared plus 1 is what I'm going to take out. I'm taking out the smallest number, so negative 3/2. And then what's left is negative x squared for the first term. I took this out entirely. Plus, we did not take this one out entirely, so I have to keep the base and figure out the exponent. So we had negative 1/2. We're going to take out or subtract negative 3/2. So negative 3/2. 3/2 minus 1/2 is 2 over 2, which is 1. I'm going to leave that off. And so I'm just going to simplify it here. This is equal to, these cancel. We get 1 over x squared plus 1 to the positive 3/2 when we put it on the bottom. So that's very easy to solve for. And there you go for 27. 29 is chain rule. I've got mama function is x something squared, and then baby is going to be quotient rule. So this is fun stuff. So I've got 2 times, I'm going to keep the baby, x squared plus 2 to the first power, times, so this is going to be u prime, the baby. The baby is bottom derivative of the top minus top derivative of the bottom all over x squared plus 2. g prime of x equals, let's simplify this. Oops, bottom squared. So now I have 2, x plus 5 is on top. I have x squared plus 2, 1, 2, 3 of them on the bottom. And this simplifies to be, I'm going to do it up here, x squared plus 2 minus 2x squared minus 10x. That becomes 2 times x plus 5 times this part, which is negative x squared minus 10x plus 2. And the book gave the answer. They took out this negative and put it out here and made this plus, plus, minus. But this is fine the way it is. 31. Same kind of problem. F of v equals 1 minus 2v, and then 1 plus v on the bottom. I'm going to do this one not on the video, and then you can check your answer. So pause and stop and check your answer if you needed to. That way you can try at like 29. All right, 31 was really cubed, so different power. So power rule says 3, and then leave the baby squared. The derivative here is u prime, is quotient rule. Then I have 3. I have 2 of these right here. I have 2 of these, and 2 of those makes 4 of those on the bottom. And then this all simplified out becomes negative 3. Negative 3 times 3 is negative 9. All right, so 33 has something all squared. So I'm going to have to do power rule with the square and then take the derivative of the inside. When I take the derivative of the inside, I will also have this piece. So I'm going to have 2 babies, I think. So power rule first. 2, keep the baby. X, I need another parentheses. X squared plus 3 to the 5th plus x to the first power. So this is derivative of the mama. This is keep the baby. Times the derivative Okay, 33. So 33's got lots of things going on. It has this composite function inside of something squared, and it has this composite function inside of something to the 5th. So when we take the derivative, we're going to have lots of steps here. First, I'm going to take the derivative of the mama function, the something squared, by saying 2, and then leaving the inside, x squared plus 3 to the 5th plus x to the first power. That's the derivative of the mama. Keep the baby. So this is keep the baby times the derivative of the baby. So this is going to be baby prime. Baby prime is the derivative of this piece is going to be 5 x squared plus 3 to the 4th times 2x plus 1. So this whole thing was the derivative of the baby. So the baby had its own baby prime, and this is its baby prime. So another way to think of this problem is, this is the long way. 2, keep the baby, x squared plus 3 to the 5th plus x to the first power, times take x squared plus 3 to the 5th plus x, and I'm going to have to prime that. So we took the derivative of the outside function and kept the composite. Now we have to take the derivative of the inside, take the derivative of the baby, but we haven't done it yet. This route is a longer route, but it may prove less confusing. So f of x equals, and all this part stays the same, 2x squared plus 3 to the 5th. Then when I take the derivative here, I have to take the derivative separately. So this derivative is going to be 5x squared plus 3 to the 4th. So that's chain rule, keep the baby, times its baby, plus the derivative of x, which is 1. And I'm going to leave that here. You could do some math manipulation around to try to make it convenient, but this addition is different than this addition. We could make this into 10x. That might make this one piece better. But other than that, there's not a whole lot of factoring we can do here. So I'm going to leave this one like here, noting that this probably would be better. Just this one thing is 10x. The directions for 42 say, find the slope of the tangent line of the origin. So that means I need the derivative, which is going to be cosine of, keep the baby, times derivative of the baby, so 3 cosine of 3x. And they want to know f, I'm going to call it f prime of 0. So when I plug in 0, I get f prime of 0 equals 3 cosine of 0, which is 1. That's going to be equal to 3. So the slope at the origin is 3, and they ask us to compare it to the period, which if you look at their picture, it is also 3. So that's kind of interesting. And then B for 42, there's two parts to that. B says y equals sine of x over 2. And if you look at that, we're going to have y equals cosine, keep the x over 2, times derivative of 1/2 x is 1/2. So that's 1/2 cosine of x over 2, which again is, if you plug in 0, so y prime sub 0 is what I'm plugging in. That's a 0 here, is 1/2 times 1 is 1/2. And when you look at that picture, it was like this. You get 1/2 of the period is the same as the slope. And that was what they wanted for 42. 43, they want slope of the tangent line at 0, 1. So we're finding y prime, which is, this is chain rule. It is e to the keep the baby times derivative of the baby. So 4e to the 4x. They want it at 0. So we're going to say 4 times e to the 0 equals 4 times 1 equals 4. That's what they were looking for 43. 44 is the same kind of problem. And so it's already worked out. I get the same -3 as the derivative of the baby here. Natural log of x cubed is going to be 1 over x cubed times the derivative of the baby, 3x squared. It simplifies to 3 over x. Plug in the 1, and this slope equals 3, which is the exponent here. So these are inverse functions, so that makes sense. Here, I haven't done this one yet, so y prime equals 1 over x to the 3/2 times derivative of x to the 3/2 is 3/2 x to the 1/2, and that simplifies to 3/2 and then x in the bottom, because we subtract those, we get an extra 2 over 2 in the bottom. And if we plug in 0, we plug in 1, is that the value here? Yeah, so 1, 0, we plug that in and we get 3 over 2. So 46. Okay, this next group you can pause and check 49 and 51 if you'd like. 53 is product rule with 2 chain rules. So we have product rule, and being able to spot this, pause and look at the problem and figure out what it is for the first time. There is this function times this function, which is product rule. So when I do h prime of x, I'm going to do first times derivative of the second, which is Derivative of cosine is negative sine, keep the baby, times derivative of the baby, plus the second cosine of 2x times the derivative of sine of 2x. So sine is going to be cosine, keep the baby, times 2. So I end up with h prime of x equals, I've got 2, I've got negative 2, that's this, and then I have the same thing, so that means I have sine squared of 2x, plus I have 2 cosine squared of 2x. The book gives a different answer for this because they use a double angle substitution. And we'll practice that more right before the exam, but really the Pythagorean identity is the only one that you need to pull out of your hat and use during the exam. So I'm going to leave this like this. This is perfectly fine for this problem. 55 gives me cotangent over sine. I'm going to rewrite that as cotangent of x times 1 over sine of x, because I really want to write cotangent as cosine of x over sine of x. I'm writing all this so you can follow it. Whoops. I did this in my head. Sorry, I need to share that with you. Cosine over sine times 1 over sine, which is cosine of x over sine squared x. I think that's going to help me make it a little bit more simple. So when I take the derivative f prime of x, I want to do quotient rule. So I'm going to say bottom. Derivative of the top is negative sine minus the top. But the derivative of the bottom is, if you want to see it easier, maybe write it like this. It is its own chain rule, so that's going to be 2 times sine of x, keep the sine, then multiply by its derivative, which is cosine of x, all over sine of x squared, so that's sine to the 4th x. Now how does that help me? That's going to give me negative sine to the 3rd x minus 2 sine of x cosine squared x all over sine to the 4th x. And if I factor it out, I'm going to take out negative sine. That leaves me sine squared x plus 2 cosine squared x. Because I'm taking that out, I'm taking one of those out. That's squared. Okay, that's good. Over sine to the 4th, which is negative sine squared x plus 2 cosine squared x all over sine cubed of x when I simplify those two together. So I'm canceling one out to simplify it. So that's my derivative. I'm going to end with the right notation. 455. The book did a substitution right here. They said that if cosine squared x plus sine squared x equals 1, like I just talked about, then we could replace this with 1 minus cosine of x. That would be f prime of x equals negative 1, 2 cosine squared of x, oh, it's squared, sorry, my bad. 2 cosine squared of x minus 1 is plus 1 cosine squared of x over sine cubed of x. So either one of these is the correct derivative, simplified. You're welcome. 57, y prime equals 4 And then the derivative of this is 2 secant of x, 2 secant of x, times the derivative of secant of x, which is secant of x tangent of x. And the reason I'm getting that is because this is secant of x squared. So there's 2, keep the baby, derivative of the baby, which is 4 times 2 is 8, secant squared x tangent of x. Y prime equals for 57. 59 is good because I'm going to show you the same notation but with theta in it. So this is going to be the derivative of y with respect to theta, not x. So I'm going to write this as dy d theta. And I'm going to rewrite this as easy chain rule like this, so that I can say the derivative is 2, keep the baby, tangent of 5 theta to the first power, times the derivative of tangent 5 theta, which is the tangent's derivative is secant squared, keep that baby, times the derivative of that baby is 5. So this is death by chain rule. This is the inside function, and this is the second inside function. So this is u prime, and this is v prime. This is the baby inside the baby. This would be f of g of h of x. And that simplifies to be 10. Tangent 5 theta, secant squared 5 theta, dy d theta. There you go for 59. And 61 is the same thing. It has double chain rule. So this is 1/4 sine of 2 theta squared. So this is the first baby. And within that, sine is the mama function, and its baby's 2 theta that needs a derivative. So 2 baby derivatives we have to do here. F prime of theta equals, keep the 1/4, it's a stretch factor, and then take this derivative. So times 2, keep the baby, sine of 2 theta, times the derivative of sine of 2 theta. So this is going to be sine 2 theta prime. That derivative of sine is cosine, keep that baby, times the derivative of 2 theta prime, which is 2. Multiply all this out. We've got 2 times 2 over 4 is 1. So we end up with f prime of theta equals sine 2 theta cosine 2 theta. Got my parentheses right. The answer they have in the back of the book is a identity that goes with this, but we're just going to leave it like this. This is perfectly fine. Derivative for 61. Okay, 75 looks fun. The outside function is natural log. The baby is e to the x squared. It has a baby. It's e not to the x, but to the x squared. So this is the second baby. So when we take y prime, we're going to take the derivative of the outside function. The derivative of natural log is 1 over the argument, e to the x squared, times the derivative of the baby, which is, the derivative of the baby is, for e is e to the x squared, it's the same thing, times the derivative of its argument, which is 2x. E to the x squared cancels, and this derivative is 2x. All right, 76, that looks awfully complicated. Let's do that properties of natural logarithms rule and rewrite this as the natural log of 1 plus e to the x minus the natural log of 1 minus e to the x. So things on the top stay positive, and the things on the bottom have a negative in the front, because these are exponents and this represents a negative because it's division. When I take its derivative, I'm going to do them separately. So y prime equals 1 over the argument, 1 minus e to the x, times the derivative of the argument. So this is 0, and the derivative of e to the x is e to the x. Subtract 1 over the argument times the derivative of the argument, this is 0, minus e to the x. So it's negative 1 e to the x. So it's not minus there, it's times. And so let's see how that simplifies. I've got e to the x over 1 minus e to the x plus e to the x over 1 minus e to the x, which is going to be y prime equals 2 e to the x over 1 minus e to the x. Okay, but blooper, I made a mistake here. So help me find it. If I take the derivative here, I need to have plus. Because it's 1 over the argument, so it should be plus. The derivative is still e to the x. This one is right, 1 over that argument. And so these are different bases now, so this is not the right answer. How do I get the right answer? Well, on FRQ, I would totally stop here. The simplified version is get a common denominator, which is going to be e to the x times 1 minus e to the x plus e to the x, 1 plus e to the x. So this fraction gets 1 minus on the top and bottom, and this one gets 1 plus on the top and bottom, which is 1 plus e to the x times 1 minus e to the x. Okay, I'm going to suggest that you leave it here, but this is the final answer, which is going to be e to the x minus e to the 2x plus e to the x plus e to the 2x. When we have e to the x times e to the x, we add the x's and get 2x. Over, these are conjugates, so I'm going to get 1 minus e to the 2x, which on the top simplifies to 2 e to the x over 1 minus e to the 2x. If you had to solve it, this is the one you would need. If you were just finding a derivative and didn't have to solve it, you could totally stop here. But I did make a big goof by not keeping the argument right there. I messed up. Sorry about that. Okay, so 76. Okay, last two. So here I'm supposed to find the derivative and evaluate it at this point and then check it on a calculator. So I'm going to have 1/2, keep the baby to the negative 1/2, times the derivative of the baby, 2x plus 8, which is simplified to 2 goes into both of these. So I'm going to say 1/2 times 2x is x, 1/2 times 8 is 4, times x squared plus 8x to the negative 1/2. I'm going to do better evaluating it if I put this on the bottom. I wrote x, 8 squared, x squared. Okay. And they want me to evaluate it at 1/3. So that means I'm going to say that's going to be 1/3 is going to be 5 over 1 will be 1 plus 8 is 9 to the 1/2 is 3. So I should get 5/3. So on my calculator, I'm going to take the plot off. All right. So I'm going to put the original function in and check and see if I got it right. So I've got the square root of x squared plus, squared plus 8x. Calculate derivative. I can't see anything because I just graphed something a minute ago. Trying to make this dark so you can see it. There we go. So zoom 6. I'm going the wrong way. Trying to make it dark. I'm doing a really bad job of it. Still can't see it. All right, here we go. So y equals x square root of x squared plus 8x. I'm trying to check my derivative 6 at the point 1, 3. So I'm going to say 1, enter, and it tells me down here that I've got 1.6 repeating, and that's what it is to be 5/3 repeating. So we have checked it, and it does work. That's 109. 109, and then 112. Let's see if that's all they wanted us to do for 109. Well, I can't find it. I think that's all they want us to do. 112, what does it say? 112 says, same thing. F of x equals 1 over x squared minus 3x all squared. And the point is 4, 1 over 16. I'm going to rewrite this as x squared minus 3x to negative 2. F prime of x equals negative 2, keep the baby, to the negative 3 power, times derivative of the baby, 2x minus 3, which is negative 2, 2x minus 3 all over x squared minus 3x cubed. X squared minus 3x cubed. Okay. And I'm going to plug in 4. So f prime of 4 equals negative 2. 8 minus 3 is 5 over 4 squared is 16 minus 12 cubed is negative 10 over 4 cubed, or 64, or negative 5 over 32. So I'm going to put this function in as a fraction and see if it will give me a fraction answer. I'm not sure it can squeeze it in there. We'll see. 1 fraction, parentheses, x squared minus 3x, parentheses, squared. Second, calculate 6 for derivative. Interesting. And I need it at 4. It says negative 1.5625. So calculator. So let's see what 5 over 32 is. Oops, I'm off a decimal point. Did I write that down wrong before? I don't know. 6 at 4. I did. I wrote it down wrong. Oh, no. Calculator. Yeah, calculator says 0.15625. And that's what this says. Okay. And I didn't put the negative in, but that's the same. So yay, number 112. All done. Okay, congratulations for sticking through this with me. Let me know what other questions you have. Thanks, guys.